thank you for joining us again. I am wearing devil horns as I am doing a haunted Halloween walking tour this evening. So we're just going to go with the theme here and kind of ignore me. Our presenter today is Mike Piersa. Mike is the historian at the National Museum of Industrial History in Bethlehem. Mike has a bachelor's in history from Moravian University and a master's in history from Lehigh. He's instrumental in research with the interpretation and research in the museum to get them started, as well as the restoration of the historical industrial equipment that's stored inside the museum as well as outside. I've been with the museum for 18 years. Today, Mike is going to give us a bit of a virtual tour of the museum and talk a little bit about items in their collection. So Mike, if you want to take it away there.
Hi, thank you all for having me. So I guess the first thing I should ask is how many of you all have been to the museum before?
I admit that I have not.
Okay, so this is a good thing for you guys. I hope so. It'll be new for some of you then. So our museum is located on the site of the former Bethlehem steel mill. What you see on my screen here is a view from the front door of the museum, looking out towards the blast furnaces, which made iron, and then further down in the plant, from a few blocks away to even almost a mile away, were actual steelmaking furnaces and rolling mills. The plant was started in the 1860s, mainly by people involved with the Lehigh Valley Railroad, because guess who they did not want to do business with? People up in Scranton. They didn't want to subsidize the competition by shipping product over the Lackawanna Railroad. So they figured instead of buying from the Lackawanna Iron and Coal Company, they would just start their own mill down in Bethlehem, and they could buy from that company that would be affiliated with them, and then the products would have to ship on Lehigh Valley Rail trackage. So the mill got online in the 1860s and started making wrought iron rail. By the 1870s, they were making steel rail because when the company was only 5 years old, they realized they had to go into steel if they were going to survive. And a market that had become dominated by firms out towards Pittsburgh and the Midwest. So, and that's something the Lackawanna people learned too when they actually picked up the entire mill and moved it to the Buffalo area in 1902. And eventually even that mill was purchased by Bethlehem Steel. So the Bethlehem plant grew, and it's really a lecture in itself. But by 1995, the plant had to face the economic realities of the time and shut down. So Bethlehem Steel was looking for a way to reuse the property, which was 1,800 acres. A lot of it became warehousing and industrial parks, but about 126 acres were set aside as a historic core. Although not legally protected, they tried to redevelop it in a sensitive manner. The corporation went bankrupt before this could happen, but they did get our museum off the ground. In the process of forming the museum, they initiated a partnership with the Smithsonian Institution in Washington, and we actually became the first Smithsonian affiliate, which means we have the right to borrow Smithsonian artifacts, just like you would borrow books from a library, and we can put those artifacts on display. So we have about 20-something artifacts from the Smithsonian currently on showing at the museum. So we're going to go from the furnaces, which actually have a walkway set up in front of them. Before the virus hit, it was actually open to the public on a regular basis. We're waiting for the virus to subside in the city, which manages it, should be reopening the walkway, which is actually about 30 feet in the air in front of those big furnaces in the background. Then we'll scan around here and actually enter the museum. We're located inside a building built in 1913 as the Bethlehem Plant Electrical Repair Shop. When you look up overhead, you'll see why this building existed, because you had a lot of, even in that early time frame, electric powered machinery like this overhead crane here that could lift 20,000 pounds. When you come in, we have the gift shop on the left. So we have the usual things like t-shirts, books, and we actually got some patterns salvaged from a pigment plant in Easton, because many factories had their own foundry work that they would job out, and they had their own patterns kept on site. So we told them we don't have room for more patterns, but we could sell them to the public. So we actually have some of them that were donated specifically for resale, so they wouldn't go in the dumpster. The museum experience itself, as far as artifacts goes, starts in the corner here with an 1877 electric portable steam engine. This is on loan from the Smithsonian and is famous because it is the longest commercially operated portable steam engine in the country. It's on wagon wheels, so it would be towed around by a team of horses that would be parked, and the steam engine on top would be built into a machine like a threshing machine, or in the case of this engine, a sawmill, and it would operate it just like you would have a portable generator power machine today. So we have baskets piled up there to show that before the steam engine, you could thresh about 8 bushels of grain a day by hand versus 32 after steam power came along. So if you notice, the building has a bit of faded and peeling paint. That's actually all been power washed and sealed. So it has that old time feel, makes it look 100 years old, but it's still safe to touch. We have a changing exhibit gallery on the left. When this was made, the changing exhibit gallery is about radios. Right now we have an art exhibit that's being ready to open on October 17th. I'll show you a preview of that in a little while. In the meantime, this is the main hall of the museum. For about 18,000 square feet with 13,000 square feet of exhibit space. So when you walk in, you're presented with a model of a steam engine that was very similar to the one that was used at the 1876 Centennial Exposition in Philadelphia. That was one of many engines displayed there, but this engine, the full-size version, you can see from the little guy in the picture here, had a flywheel 30 feet in diameter, and the engine produced upwards of 2,100 horsepower. It was so powerful that after the exposition ended, it took the builder, George Corliss of Rhode Island, 7 years to find somebody who wanted to buy it, because nobody really needed that much concentrated power in that form at that time. Even during the exhibition, it only produced about 400 horsepower that was actually used by other machines, and that was 8,000 machines inside a 14-acre building just devoted to machinery. There were dozens of other buildings devoted to individual states, nations, art, and you name it, anything you can imagine at a World's Fair would have been there back in 1876. So as we move into the museum, you'll see what's really the centerpiece. Sorry. Still takes a little getting used to with the virtual tour here. So as we walk back into the exhibit hall, you'll see this big green machine. We're at the back of it right now. It's about 15 feet wide, 35 feet long, and this big flywheel here is 14 feet in diameter. The whole thing weighs 115 tons. And this is a Corliss steam engine that actually operates for visitors on special event days. Dates to 1914, it was built in Buffalo, New York by the Snow Steam Pump Works and pumped 8 million gallons of water a day. So as we turn around the museum, we'll be going up a ramp. And from the ramp, we'll see a machine that's on loan from the Smithsonian. This is a Lindy Wolf steam-powered ammonia compressor. So what that means is it's a steam engine that powers a refrigeration machine, just like you have in your refrigerator, but much more old-fashioned. And instead of using a modern refrigerant, it uses ammonia, and it would create the equivalent of 10 tons of ice in a day. So we're looking at the steam engine side of it here. The compressor side is on the background, and that was used at a brewery in Baltimore from 1884 up through the 1960s. So when we look on the wall back here, you're coming in through a wall of patterns. Those are wooden pieces that you dip into a bed of sand. The sand would be compacted around them. Then these wooden pieces would be pulled out, and they would leave a hollow impression in the sand that would be filled with molten iron. The iron would cool and then be used to make machine parts. So you can see the big flywheel here, and the same thing was used to make the small wheels, the big wheels, the pulleys, the legs for the machines. And you can really start seeing how this process started with raw materials in the ground, melted it down, and it actually became something usable. Over on this area of the museum, we talk about how you took those rough castings and turned them into something that you could actually use. So we have a variety of machine tools here. At the far end are a pair of lathes. Lathes take metal and spin them around, and you can take a cutting tool and go and engrave into that spinning metal a shape, and it'll create something smooth like a cylinder, or if you're working with wood, like maybe like a column. So it's very, very critical tool in machine work because that's the way you make things round. Then we have other devices that make things flat by moving them in and out on what they call shapers or planers. Then we have drill press, which is a common tool today, and then the radial arm drill, which is an advancement on that drill press. You can take that drill bit, and instead of just going up and down with it, you can go in and out and swing it along a central pivot in a 360-degree circle. So anywhere within this arm here, that drill bit can reach. We also have some world-class machines here. I was a little bit too far there. Sorry about that. Swing around. I think, of course, the experience is much better in person, but you can just barely see this blue machine here. That's a single-cylinder gas engine. That's the oldest surviving American-built four-cycle engine. That means that if you drove an automobile today that you had to stop at the gas station for, you're probably using the same type of engine that is exemplified by this guy here. His flywheel is maybe 4 or 5 or so feet in diameter, but it only creates 4 horsepower because it was created right at the moment where they figured out the technology, but they hadn't yet scaled it up and also shrunk it and made it more efficient into the form that we know today. The little green guy back there to right of the blue one is a Brayden Oil Engine. The blue one on the left actually burned fuel that came in the form of gas, not the liquid, but like a gas, like you breathe, like air, that kind of gas. But the one on the right burned liquid fuels. So by burning a liquid fuel, George Selden, who worked in the patent office, got the idea that he could actually take that fuel, that type of engine here called the Brayden, put it into an automobile or a horseless carriage, and patented the idea for the automobile. So when the early automobile builders were making their vehicles, they had to pay patent royalties to the Selden patent and also buy into a patent pool. Ford was rejected from the patent pool, so he started a lawsuit to get into it and avoid paying the patent fees by arguing he had a different type of engine than this Brayden. So this exact engine was used in the lawsuit between Henry Ford and the electric vehicle company, which owned the patents. And Ford eventually won the lawsuit with about 1 year left on the patent. So after we see what these late 19th century innovations were leading to, we go up onto a ramp that goes through our iron and steel gallery, and you see more about the process of actually making the material that went into these machines and a lot of other things like skyscrapers and bridges. So we have a series of models here that show the manufacturing process from the raw material, taking bituminous coal, which was a successor to the anthracite, which was used raw. And the bituminous coal was turned into coke by baking it. That means it had the impurities removed that we would look at as pollution. Those impurities were captured and taken to a chemical plant, and they made any of 300 different chemicals from them, anything from DDT to diet soda sweetener. Then the coke, which was mostly carbon, was sent to the blast furnaces, combined with iron ore and limestone, and produced liquid iron. The iron had to be further refined and alloyed to make it into steel, which happened in open hearth furnaces and basic oxygen furnaces. Open hearth furnaces took about 8 to 12 hours to basically bake the carbon out of the steel to the right amount, while a basic oxygen furnace, which was a 20th century innovation, did the same job in about 39 minutes. So we have displays showing some steel products, like a model of the Free Bridge between Easton and Phillipsburg, a pattern on the wall showing a railroad switch frog that was manufactured at Bethlehem Steelton plant and cast in manganese steel to make it extra strong. A little transportation area. It's hard to see here, but this is an actual 1880s blueprint of a camelback steam locomotive used by the Reading Railroad. Then we'll come down the ramp a little bit, and we'll start seeing why steel was so important. We can see a piece of wrought iron rail here. And if you look closely where my mouse is, you'll see it's actually cracked. You'll see how wrought iron delaminated and split. And then they moved into Bessemer steel and eventually open hearth steel, which was much, much higher quality and longer lasting. So as we spin around, we'll take a look at a model of a rolling mill that was a patent model for the type of mill that produced railroad rails from the late 1850s onward. They had problems making railroad rails early on, in that you could roll them or squeeze them through a mill to make the rails longer and into rail shapes. But after they passed through, you had to get them to the other side of the mill, and in the process they would cool, and you wouldn't be able to make the final shape to the quality that you wanted. So this type of mill added an extra roller so they could reverse the flow of the rail and keep on rolling it back and forth rather than squeezing it out in just one direction and having to backtrack with no productivity on the other way to produce it. And if you guys have questions, chime in. I know it's a little hard to explain this stuff if you don't see it very well in front of you. So as we go down our ramp, we see an exhibit about skyscrapers here. You can see the different types of columns that were used. You can see a riveted column. The rivets, of course, show up much better in person. You can actually touch them and feel them. And we talk about how the columns evolved from an I shape to an H shape. It doesn't sound like much of a difference, but that change in shape gave them about 10 to 15% more structural efficiency and lower costs. So it was a big deal to the architects and builders when you were building those 50 stories tall or more. 10% savings meant you could go 5 more stories at least, just in the savings that those beams offered from their design. We're not going to go into every single detail, but we will point out a few little things here in the case. This is a case about Bethlehem mines. You can see a safety lamp like you would have found up in Scranton. Bethlehem actually had mining operations in the Anthracite region near the Tamaqua area. And of course, a lot of mines in Western Pennsylvania, Kentucky, and that region further to the west. We also have a giant steam forging hammer here, 1851. That's the oldest one in the country, imported from England by a company in Connecticut and then used in New Jersey. Let's go back here and see if it, sorry. I'm literally just going through walls at this point. We'll get there eventually. This is where I wanted to go. Does anybody want to take a shot at what this plate is here? Any guesses? It's actually a piece of armor plate built by Bethlehem Steel and test fired. So you can see a projectile went through from the right side to the left side and got embedded in this thing. The plate is 6 inches thick and has an 8-inch shell that goes through it. Bethlehem Steel said it stopped the shell, but the Navy decided not to buy any more armor of that design, and that ended up being the last piece of Class A armor manufactured in the United States. And it was actually a test piece for the USS Forrestal, which went on to use a more modern type of armor. We have models of ships built by Bethlehem Steel, actual full-size warheads produced in the plant in 1959. A display of the welfare baskets. These are actually hanging metal baskets in the air that workers use instead of lockers to put their work clothes in at the end of the day. Just like they did in the coal mines, they would hoist them to the top, let them dry overnight, and put on the same dirty clothes in the morning and keep wearing them until, as some guys said, the pants would stand up on their own, even when you're not wearing them. So another similarity we have to your region up there is that while the men worked in the steel mills and the mining industries, the women and children often worked in the silk mills. The silk mills migrated here from the Patterson area because they followed those anthracite railroads to a place where labor was more docile and you had people who were looking for work. So we have a display that shows what you might have seen in a typical silk mill on a smaller scale. So we go through the production process. So we have winding machine that wound the thread up onto bobbins. The bobbins would be then put onto they call it a spool creel. We can see a few hundred different bobbins of different colors lined up, go onto the warping wheel, which would create the warp thread, which came out towards you in the loom, you'll see momentarily. Then the weft thread was the thread that went crossways. We also talk about labor issues. So we have a cutout of Mother Jones there, strikers, bobbin tray that kids can actually pick up and feel the weight of these bobbins, and imagine doing that for 9 hours a day. Then we have a more technological look at things, seeing how the punch cards were made, and a hand and foot powered piano card punch machine is what they call it. But you would manually translate the design, and I'm not sure if you can tell from the image here, but does anyone guess where we got that design from? It's only about maybe a mile or two away from you guys.
Is it Scranton Lace?
That's from Scranton Lace. So Scranton Lace would have used the same type of process. This is actually a design made on graph paper, colored in all by hand, and then somebody would sit at this machine here on a leather bench, which the cards are stacked on, and manually translate that design from the graph paper into punch cards, one line at a time, to be put into the loom to automatically control what type of fabric it makes in the design. So our looms came from Scalamandre, which was a luxury textile firm in Long Island City, New York, and they produced fabric for the White House. And this piece of red here was used at the Jacqueline Kennedy redecoration of the Red Room. I believe a lot of it is still intact in the White House, and this was overrun from the same run of fabric, so the company set it aside and eventually donated it to us for display. We have a broad loom for making fabric. That fabric cost $1,000 a yard when it was brand new in the 1930s. They were selling to people like William Randolph Hearst. And we also have looms like number 27, which made ribbon. So Scalamandre had customers like the Metropolitan Opera and a lot of really high-profile people. But there were also ribbon looms in Allentown here. And the looms in Allentown actually made the blue ribbon that was used on Pabst Blue Ribbon beer. So we have one final exhibit that's permanent in nature. That's our propane display. One of our early board members was the son of the guy who discovered the gas back in 1910, patented in 1912. And he said he has an amazing collection from his father. And the story goes all the way back to the laboratory glassware that he made the discovery on. So we have a sampling of that displayed here. So we can tell the propane story from the moment the idea was born in the inventor's mind all the way up through the present day. So hopefully you guys can get a chance to come and explore the museum and see all of the details. If you read all the plaques and look at all the artifacts up close, I mean, you could be here for 2 to 3 hours. Plus, we do a lot of special events, like the coreless engine running. We have the orange diesel electric locomotive outside from Bethlehem Steel's narrow gauge operation we operate, and a lot of special programs. So what I want to do now is
Mike, is the museum open to the public now?
Oh, yes. We're open Fridays through Sundays, 11 to 4.
Okay.
And we also do special tours. But before I go, I want to take a few more minutes to show you what's new at the museum. So we have the usual progress. This will take maybe 10 minutes or so of things we do on a regular basis, like restore artifacts. So this is a steam-powered vacuum pump that we just finished repainting. The color is historically accurate. We do careful research on it and come as close as we can to the original color on these things. But in addition to that, we've been getting some new collections, in which I thought you all would find very interesting. This is from Captain Bill McKelvey. At the age of 12, he started collecting pieces of railroad rail. And he's in his early 80s now and was looking for a home for all of these things. And he figured our museum would be a perfect fit, and we agree. So he has samples of railroad rail from all around the world. I think we have about 114 pieces we have on hand already, and he discovered another 20 that we have to go and pick up still. So if you look at these pictures, you'll see a whole variety of it. It's like strap rail, which I'm hovering the mouse over now, that came from one of the gravity railroads near Scranton. The rail that says 911 WTC came out of the World Trade Center because they had the PATH train running underneath it. So that rail was there during the attack. Then we have a whole range of other pieces, anything from streetcar rail to elevator rail to this very heavy piece I'm circling now, which is probably for overhead cranes. Streetcar rail, which has a unique flangeway rolled into it. We even have a salesman sample of rail there. rail from the cable car in San Francisco, sections showing how rail is jointed, and then one I think you guys would have a special interest in, rail from the Canal Wharf at Stourbridge, England, near the plant which built the Stourbridge Lion, which is a true Northeast Pennsylvania story right there. So we actually have a piece of the rail that locomotive might have rolled on when it was shipped in England. So we've received some other pieces lately. This is not so much as an artifact, but it's really a living memorial. It's the Bethlehem Steelworkers Veterans Memorial. It was located about a block away from the museum, and a parking garage is slated to be built where it was located. So this was actually picked up and moved to the museum just a few weeks ago. And many of the men who built this thing in 1989 are still around and have very fond memories, and have been able to really tell us like how it got built, all the amazing stories behind it, and the people who worked there. And we moved it to the front of the museum, outside in a public area where it can be accessed 24 hours a day and lit up at nighttime. So I'm not sure if you guys saw it on the news, if the news made it up to Scranton, but we were told earlier this year that the expansion of the casino in Bethlehem for a new hotel tower meant that this 900,000-pound vending press had to move. It was built by Bethlehem Steel, mostly using patents from Joseph Whitworth in England. If you've ever had a thread, a nut, or a bolt and wondered where standardized threads came from, this was a guy that was initially responsible for the earliest standards in the 19th century. He went on from nuts and bolts to actually making armaments like battleship armor, and his process was purchased by Bethlehem, and the designs were shared. And in 1890, they actually built this press for bending armor plate. It could bend pieces of armor for battleships up to 21 inches thick. So in order to move this thing, the casino thankfully funded the move because it was in their best interest to see this thing preserved and relocated. We first had to go to the museum and find a site for it. The only place it could possibly live was outdoors. So Bean Excavating dug a hole for us. And then we had to make room for a 20 by 20 foot concrete pad, about 2 feet thick. So you can see the bottom of the pad being framed up there. It's about 8 feet down in the ground. And then there was a riser that the actual press would sit on. I'm going to say maybe 7, 8 feet wide and 16 feet long. Metal columns, metal plates embedded in the foundation for the press to be welded to. And then A&A Machinery Company from down near Philadelphia in Morrisville came in, and they brought in this 300-ton capacity gantry that lifted the top of the press off, set it onto a giant transport that came in from New Jersey. I think I counted 80 wheels on this thing, and the operator actually walks behind us with a corded control box and steers it remotely, so nobody actually rides on it. He just walks along behind it. And this thing, I can move it at snail's pace, or once it got into a straightaway, it picked up to, I'd say, a little bit more than walking pace with this thing. Rounded the corners, drove through the steel mill, and this piece here weighs, I think they said 425,000 pounds. Then the 400-ton capacity crane came in and lifted the smaller pieces of the press. This is the anvil here that would slide in and out under the press. So they used it for making battleship armor initially, but later on they would use it for straightening narrow gauge railroad cars that served the steel mill that got distorted because of the heat and loads. And this thing, despite being built in 1890, was in service until the very end in 1995. So they came in and backed this rolling trailer, they call it a hydraulic transport, under the gantry here. And the gantry raises up with hydraulic cylinders, lifted this piece up. Then they set it down, lifted it up again after the other crane set the smaller pieces, lowered it down. And the guys, you can see there, were very, very careful, watched the job every inch of the way with levels, and welded it back together. And now we have a 20-foot tall, 900,000-pound artifact sitting in our front yard that really dates to the beginning of the age of the modern Steel Navy. Without this artifact, we might not have won World War I and had the basis for subsequent wars. So we've also done some other interesting things lately that work with metal. This is a Bloomery furnace that was hand-built actually last Saturday by volunteers who came in from New Jersey. We took iron ore pellets and coke that were actually just lying around here at the Bethlehem Steel site under the Hoover Mason trestle, put them into this furnace. I'm sorry, this is a charcoal-fired furnace. We used coke for another furnace, and we actually smelted iron with it. So this is, amidst all the flames, I'm going to guess about a 30-pound, they call it bloom of iron. So it's actually wrought iron that we smelted down from the raw materials. And these guys are hammering it out now and trying to get into a usable shape, and they can make actual products from it, just like you would have done hundreds of years ago. We also got a coupolette furnace donated. Those of you who went to Arts on Fire at the Scranton Iron Furnaces probably saw furnaces like this. Now we have our own, and we're actually able to melt iron with this. So we busted up old radiators, used coke from Bethlehem Steel that was left over, and actually melted iron, parted out, and made our own castings. So we're getting ready to make medallions for the last cast 25th anniversary here in Bethlehem. It was 25 years ago on November 18th that they shut down Blast Furnace C, which was the last furnace to actually make iron here in Bethlehem. And back then they made commemorative medallions, so we figured we'd make an updated version of them to commemorate the anniversary. And so far they've been very popular, and we're going to be doing another part in early November to start mass producing them. Then we also have changing exhibits inside the museum. If you look up in the air, that's actually a subway car being lifted up by a crane and getting ready to be dumped in the ocean, because the next exhibit we have is about recycling, and it's images from a photographer who's gone around and shown the life cycle of steel from being assembled together in shipyards to being used as railroad cars and then returned to a state where it could be reused in a recycling center. So he goes through the whole life cycle of steel. And this exhibit by Stephen Mallon is going to be opening October 17th in the museum. And as nice as it is to see pictures online, to see these things in person several feet across is really a whole different experience, and I think very worthwhile. Last thing I want to mention to you is in conjunction with the last cast anniversary, the local public library was trying to do a children's book, and they asked us for some advice on what a good topic might be to talk about the demise of Bethlehem Steel and how to tell that story. So we suggested telling it through one of our vehicles, which is this airport pushback tractor called the Tug. Bethlehem Steel got it, and instead of pushing around airplanes, put a railroad coupler on the end of it and used it to pull trains around inside Bethlehem Steel. Our volunteers have actually restored it, repainted it, and got this thing running so we can actually drive around, we can pull things with it. And we told the library that this thing would make a really interesting story. So they actually came up with a children's book around it, talking about how the Tug came up here, changed its career from working in airports to working at Bethlehem Steel, went through the closure, and then found a brand new life working for the museum. So we think that's going to be a real exciting thing when it gets released, hopefully next month. And a lot of other activities are going to be going on with the Last Cast 25th anniversary celebration, like a Steelworkers reunion party at Arts Quest, Steelworker interviews. We actually have workers coming to the front porch of the museum from 12 noon to 3 o'clock every weekend to share their experiences with whoever is interested in talking with them. They've been having a ball doing it, and the public has been learning so many things that you could only learn by talking to these guys in person. So that concludes my presentation. Does anybody have any questions?
That's excellent, Mike. Thank you. Thank you for sharing. I'm glad you have the pictures of the Bloomery Iron Forge. The Slocums had one in Scranton in the 18 teens. I don't think I've ever actually seen one. So it's nice to know what I'm talking about when I say Bloomery Forge to people.
I'm glad that was helpful. But yeah, that thing was really impressive. It's actually made from mud, a mixture of mud, manure, a little bit of straw. And yeah, it was quite a process. The thing ended up getting destroyed just to get the bloom of iron out. But when they built other ones out of stone, you have a more permanent structure. And instead of using electric blower like we did, you would actually have bellows like you would see like in a fireplace, but larger, pumping the air into it. But you would have the same flame coming out the top. And that would have been pretty spectacular to see. And of course, when they hammer that iron out, I mean, you get a real sense for the brute labor it took and the muscles these guys would have had to work this stuff.
Yeah, that's impressive. I'm glad you're still doing the iron demonstrations so people could see it. It's one thing to tell the story, but something else to be able to see it in person.
Oh, absolutely. See it and feel the heat.
Sure. Yeah. Does anybody have any questions for Mike about the museum or anything that's on display, or what other stories that they tell?
No, but I have a comment. I think he did a great job considering we had to do a virtual tour. He did a very, very good job, Mike. It gave us a good sense of the museum. Very good.
Well, thank you. I'm really glad to hear that. Well, hopefully when you guys feel up to it with the virus and everything, you can come down and see it in person and watch our calendar of events for special things like the casting and ironworking, and really come down and enjoy yourselves and learn a lot too.
I will put the link for the museum's website on the in the video itself, so you could follow up afterward. The virtual tour that you went through is part of your website, correct?
That's correct.
Okay. All right. You can go back and look at things that you may have missed when we were going through. So that would be great.
Mm-hmm.
Anybody else? All right. Then again, Mike, thank you very much for joining us and for sharing the images of your museum. I do hope everybody can get a chance to go down. I have not been there myself. Mary Ann has, and she was narrating in the background about how much she loved the please touch aspect of it. So it is a great site to go see. Our next Zoom program will be on October 16th. We'll be joined by Mark Rossetti from the Luzerne County Historical Society. He'll be talking about 1860s baseball. October is usually a spooky month, but it is also a sporty month. So we will be talking about baseball during our next Zoom program. So